Hello, Wayland Middle School's Mr. Farley here, and I'm going to do an answer key here for the Solving Quadratics practice page that we just did the other day. So let's take a look at this first one here. We're in trouble when it's not equal to 0, so let's add 18 to both sides. So if that's the case, I have my x squared minus 9x plus 18 is equal to 0. And now let's get going. It looks like solve by factoring. Those are the directions here, solve by factoring. I'm looking here for factors of positive 18 that add to negative 9. Hopefully everyone's thinking negative 6 and negative 3. That product gives us positive 18, and the sum gives me negative 9. I think we're in pretty good shape, equals 0. So that means the value of x is 6 or the value of x is 3. Just solve that first one by factoring, then using the ZPP. Let's do the same thing here for the second one here, number 2. Let's once again get it equal to 0. So I have an n squared plus 10n plus 16 is equal to 0. It's always better when it equals 0, so we can solve this. By factoring, again, I'm looking for factors of positive 16 that add to positive 10. I'm seeing a plus 8 and a plus 2. That gives me my two factors, again using the ZPP. The value of n could be negative 8, and the value of n for the second one is negative 2. So those are the first two. I'm going to scroll down here a little bit and try 3 and 4. All right, let's see. So 3 and 4, let's get going with these here. Again, get it equal to 0. I have a k squared minus 4k minus 5 equals 0. When I look to factor, I see, oops, that's a k minus 5 and a k plus 1. That takes care of that. That gives me, these multiplied together give me negative 5, and these added together give me a negative 4. It's solving with the ZPP. K is 5, k is negative 1. Solve that one. So factoring these quadratics pretty easy, especially when all of these are factorable. Hopefully this last one is too. I have an r squared minus r minus 30 is equal to 0. I'm looking here, I'm seeing factors negative 6 and a positive 5 equals 0. And if I solve this here using the ZPP, r can be 6 or r could be negative 5. That takes care of the first 4 of these. That was all by solving by factoring, and make sure you get all of those equal to 0. Good job. All right, let's continue with number 5. So here we have to solve by completing the square. This requires a little more effort than just by factoring. So let's see. When we do these here, I think it's always best to move this constant to the other side. So if we're going to do that, we have a b squared minus 8b. By adding 70 to the other side, I have 65. Let's complete the square. We complete the square by taking half of this b, the coefficient, right here. Half of this gives me negative 4, and then squaring it is a positive 16. If we think about it, we can't just add 16 to an equation without adding 16 to the other side. Make sure you do that. That balances the equation. We have forced a perfect square right here, and I'm seeing a b minus 4 squared is equal to 81. That's really good news, because now when I square root both sides to solve this, I get the absolute value of b minus 4 is equal to 9. Split this up into its two equations. B minus 4 is equal to 9, and B minus 4 is equal to negative 9. Adding 4 to both sides, B is 13. Adding 4 over here, B is negative 5. So this is solved by completing the square for number 5. That worked out pretty well. Let's do the same thing here for number 6. Get this constant of negative 12 to the other side. I get a k squared plus a 2k, leaving some space. You know I like to do that, is equal to 22. Let's take half of this coefficient right here of the k term. Half of that gives me 1, and when I square it, I get 1. Can't just add 1 to one side of the equation, must do it to the other. And look what I have. I have a perfect square over here, which is a k plus 1 squared is equal to 23 by square rooting both sides. Doesn't work out as nicely as the other one, but it's still pretty good. You get the absolute value of k plus 1 is equal to the square root of 23. When I break this up into two equations, x plus 1 is equal to the square root of 23, and x plus 1 is the negative square root of 23. Solve it. K equals negative 1 plus root 23, and k equals negative 1, minus, it's a minus root 23. All right, so not bad. Those two looking pretty good. And let's continue. All right, here's number 7. Number 7, let's add 87 to both sides. X squared minus 2x. By adding 87, I get 84. Take half of this x coefficient right here. Half of that is negative 1. Squared is 1. Add 1 to both sides. Another perfect square, just like the last one. There we go, is equal to 85. Go to square root both sides. Gives me the absolute value of x minus 1 is equal to the square root of 85. Split that up into its two equations. One that equals square root of 85, and the other one equals negative square root of 85. Solving it, add 1 to both sides. This is what I have here, and I'm adding to this other side too. Here we go. And there are your two solutions.